What's up, YouTube? Today I'm going to be showing all about this shipping container I have that is powering our ranch completely off the grid. Now, here is the inside of the container. I went halfway. It's a 40-foot container, 8 feet wide, 8 feet tall, and halfway I built this room for all of our electrical. We'll start here with our batteries. Here I have these shelves. They came from Costco, and built onto the shelves I have these pieces of unistrut with some L brackets with isolating bushings, holding some 3/8 thick by 3-inch wide aluminum bus bars. I have this set up as my essentially a wire, except it's a solid bar. That way it can better carry the capacity. These are size 8D batteries. They're 12 volts a piece, and they're capable of 255 amp hours. But I only drain them about 50% at most. I have a couple that are newer and a few that are older, but it's all balanced out. I have a battery equalizer up here that makes sure all the batteries are at the same voltage, so none of them get overcharged, and that's what these thinner wires going between them are for, is for equalization purposes. From the batteries, I have my connections here, just bolted directly onto the bus bars, and here I have a Chinese-made 12,000 watt continuous 36,000 watt peak inverter. And by the way, these batteries are at 48 volts nominal voltage, and it has cooling, and this inverter is very good because it's transformer based, which means it doesn't rely on diodes or transistors for its main transfer of power. This is also a battery charger capable of 120 amps at 48 volts, which pulls about 6,000 watts on the generators when it's charging the batteries. The input for the charger and output of the inverter comes through this 2-inch EMT conduit to this pull box, and then I have another conduit coming down, which is my 2-watt aluminum wire, and that is used to bring the solar panel, the solar power to the batteries. Again, these batteries are 48 volts nominal voltage, and I have one shelf, but the plan is later on down the road, as our needs increase, to fill this second shelf and have a total of 32 batteries, which is the equivalent to about 98 kilowatt of capacity for storage. And from this pull box, I come through this EMT here into these are 3-foot sections of gutter. I have 4 of them, and the output of the inverter comes into this panel, and inside this panel it comes into this main disconnect, and from there it's branched out to various different circuits. Here I have 2 smaller disconnects, and what these are for the generator. I have 2 of the 2,000 watt Honda inverter generators and 1 3,000 watt generator, and they come into this 30 amp breaker at 120 volts. They go through this liquid tight conduit to this transformer. Here is the nameplate on this. This is a 25 kVA. It's a step down transformer, but I have it ran backwards for step up. Based on this wiring diagram, it pulls in 120 at the bottom. Let me see if I can focus. It pulls in 120 at the bottom and outputs 240 volts single phase at the top with no neutral. And from there, it goes back through this same liquid tight into this other breaker, and then runs through this EMT back over to this battery charger, and this battery charger takes that 240 volt single phase and converts it to 48 volts DC or so, approximately there, to charge the batteries. And I use that on rainy days or when I need extra power to power things. So that's what those are for. These are my 2 Outback FlexMax 80 charge controllers. These go from the solar panel input to the batteries through these 2-watt wires right here, these ones. And what those do is those regulate the energy coming in. So as you can see right now, it's actually a cloudy day. I'm pulling in 97 volts at 0.8 amps, actually 0.9 amps, and I'm outputting 52 volts at 1.8 amps. So it's actually converting voltage to amperage to better charge the batteries. Now this is an MPPT charge controller, which means it's getting the maximum amount of power out of the solar panels. There's a lot of cheap charge controllers that are about $80 or $90 that are called pulse width modulation, and instead of converting the extra voltage into amperage, which therefore charge your batteries, they just drop off that voltage and it's wasted. So I definitely recommend, if you're going solar and off the grid, these are the FlexMax 80. These are amazing charge controllers, and these two actually are designed to be paired together so that they can work in parallel. That way when the batteries start to get full, they can say, okay, it's time to shut down, and better taper off their charge. Here I have a 3000 watt inverter that is also a 120 amp 12 volt battery charger, and I use this if I need to pull batteries out of the rack to better balance them out and equalize them. Say one battery is reading a low voltage, I can yank it out of the rack, put it on this charger, give it a nice full charge. And I also have an outlet down here that is off of this inverter that can be used to discharge a battery if I have a circumstance where I need to do so. All the electrical conduit was done by myself. I learned how to use a pipe bender. It's much cheaper than if you were to buy all the fittings and add couplers. It's also easier to pull the wire. Here I have an exhaust fan. It's approximately 1200 cubic feet a minute, and that is to pull out any hydrogen gases the battery makes. And also in summertime, I keep this room closed during the day. That way the heat stays out, and then at nighttime I open it up and turn on that fan and pull nice cool air in to remove the hot air from the room. This is my battery filler. I use this because you need to check the electrolyte levels in these batteries. All I did was I took a 5-gallon Home Depot bucket and epoxied in 2 quick disconnect air fittings. And originally I had this set up so I can put about 10 psi of air into the unit. That way it could push the water to these top batteries, but it actually takes a significant amount of air pressure in order to push water through the hose. And what would often happen is the lid would come off. So it was a great idea, but in practice it didn't work. But I like this a lot because airlines are designed to be pretty much sealed completely from the outside elements, and this is distilled water, which I want to keep as clean as possible. So when I need water to fill the batteries, I just disconnect this quick connect fitting and then use the hose to pour the water, distilled water, into the batteries. I check these batteries about every 2 weeks for electrolyte level, because if you run the electrolyte low on the batteries, you can very easily destroy a very nice battery really quickly. If you're running off the grid, I strongly recommend one of these hydrometers that are temperature compensated. What this does is it gives you 2 things. It gives you the specific gravity of the electrolyte in the batteries, which is a very good indication of how charged they are. It also gives you a temperature of the electrolyte in the battery. So if one battery is having a problem, it'll oftentimes get hot, and you can better track what the status of the battery is based on cell temperature. So if all the batteries are, say, 70 degrees Fahrenheit and one cell is at 90 degrees Fahrenheit, you can better identify that battery has a problem. And oftentimes if you have a cell that's getting hot, that means there's another cell that is not charging properly, and at that point I would pull the battery off the rack and put it on this other charger. That way that battery can go back to full operating condition, and then the other batteries aren't having to work harder because that one's working less. So if a battery's getting hot, that usually means something's wrong, and that means you need to check it out. Here I went a little crazy with the conduit bender and made a hanger rack because we have our washer and dryer, both are electric, connected here, and I did all this conduit work on my own and installed these lights and ran everything necessary for a washer and dryer. And later on down the road we're going to have the washer and dryer from our other property, and that'll be in here, and that's what the water heater is for, because they don't heat their own hot water, but they're a much larger capacity, so that'll be nice to do laundry quicker and use less energy. Here's my NEMA 3R gutter outside, and this goes to 3 outlets that are 50 amp RV style plugs, and we're powering 2 RVs up here, and I have another that goes through this strain relief that goes to our shop. We have another shipping container that's built out for our shop, and I have another gutter down there that I'm going to get into right now. Here's another NEMA 3 gutter, and this is where all of my solar inputs come through this cable right here. And then the plug on the end is for the generator inlet. That's an RV style plug using a 50 amp RV power cord. Here are 16 of my solar panels that are mounted on the top of a shipping container. This is where our main power source is. I have 16 210 watt solar panels. These are about 7 years old. They were recycled. We got them very, very cheap. And they're wired 4 in series and 4 series strings in parallel. And these go to one of those FlexMax charge controllers. Here is the exhaust fan I have on the room. It's a Lauren Cook company. Usually it's used for a grease duct on an exhaust, like for a kitchen, a commercial kitchen. I got this sitting in a shop for about 5 years. It was never used, and I asked and I received. Disregard that wire in the background, that's extra. That's the air compressor. These are the 3 Honda generators that I have set up running in parallel. These I use on cloudy days, kind of like today. When I don't generate enough power with the solar, I can start the 3 of these up and get it's 7,000 watt peak, but it's about 5,400 watts continuous. And this will run that battery charger on pretty close to full blast. But one of the downsides is the battery charger transfers over to the generators, which means all loads are then on the generators. So if these are running and you start up the dryer, for example, it'll easily overload these generators. I would like to replace this with approximately an 18 kilowatt diesel generator. That way I can run up to 12,000 watts, which is the load of the inverter at full capacity, plus another 6,000 watts for the battery charge of the inverter. I'm going to start these up so you can tell what they sound like. These are the generators about 5 feet away at close to full load, but it's not full load because the sun is still out some and the solar panels are still making power. So they're a little noisy. Even though they're supposed to be really quiet, but for what they do and their fuel consumption, I can't complain. They work really well. It sounds like they slowed down a little bit, almost like the batteries are near full. So now with those generators running, power's coming in through here and going out to the battery charger through here. You may be able to hear on the video that this transformer is humming along. It's stepping that generator power up to 240 because those Honda generators only outlet 110. And apparently I have dirt on the camera. So yeah, the battery charger, the blinking orange light means it's in absorb mode, which means it's at least 60 volts. So this is not full capacity, but I do have an adjustment switch down here to turn. I think I can get it. There we go. Now it's at full bore, but it's not because it's in absorb mode and this is a constant voltage, not constant current. And you can see the output voltage on these charge controllers has gone up. That's now charging the batteries through the bus bars and through the connections. So thank you for checking out my video for my off-the-grid solar setup. If you have any questions, leave them in the comments below. And subscribe for future videos on this system as I do upgrades. I do plan on putting those 16 solar panels on a tracking rack. I'll weld that up probably before next summer. So if you like this video, thumbs up, hit the subscribe button, and I'll see you later.